You're going to be finishing up the information for test 1 by the end of this module. This is the overview for module 2, and you're going to begin by actually reviewing concentration units from General Chemistry 1. These concentration units look like these. So we've got molarity. Hopefully you remember that one. We have mole fraction. That was in the gas chapters when that was first introduced. And then we have percent mass. That was kind of touched on. It's very similar to percent composition, which is where you're figuring out like empirical formulas and stuff. So you might remember that one or you might not. This is actually one of the most common types of percentages though. So it's just like a percentage. And I didn't do the times 100%, but it has a times 100%. And then over here we have molality. And molality is the new unit. So 2 familiar units, 1 new unit, 1 unit you may not remember very well. Then we're going to move into formulas. So what this is if you've got a solution, so we've got our solutions, you learn about solutions up here. So a solution is going to have some things change as compared to the pure liquid property. So we learned about like boiling point, freezing points, we learned about vapor pressure, we learned about those over here as a pure liquid, and that pure liquids have them. Once you make it a solution, basically those properties, if you change the concentration of it, will kind of shift a little. So what happens is your osmotic pressure is going to change of the solution as compared to like pure water, if you have a solution of like salt water, or maybe something that's a little bit more soluble in salt, but a solution is going to have a different osmotic pressure. A solution has a lower vapor pressure than the pure liquid. The boiling point of it goes up and the freezing point of it goes down. So these are all equations to let you calculate how it changes by. This is kind of like PV equals nRT. If you were to, the P being like pi, like big capital pi, nRT. So if you divided both sides by V, that would give you P or pi equals N over V times RT. Well, what is molarity? It's moles per volume. So those are kind of similar if you need a hook for what you've already learned before. The R in that one uses the gas constant R, that 0.0821. You want to be really careful with all of your R's from this point out, because whenever you're talking about thermodynamic type things, which is what's coming up, you use 8.314 for the R. But when you're doing like pressure-y kind of things, then you use 0.0821. So there are different R's in this course. Please pay attention to which one to use when. Now, you actually also learned about this equation right here. You would have learned about that in the gas chapter. The format it might have had in the gas chapter would have been like the total times the mole fraction is like equal to A, the pressure of A. So that's how you would have seen it before. Now, this one has a little bit of a twist on it once you get into it, but it's not hard and it's the same style of formula. This final one is a new formula. You're going to learn about I. It's a funny little guy. It's really easy to figure it out. It is a whole number, but it's kind of weird. You already know how to do molality because you learned and practiced it over earlier in the week. And then this is a constant. And this equation actually is used for this one as well as this one. It's just when you're using it for the freezing point, it's KF, F being freezing. All right, last part of the week, the third lesson is going to be on concentration conversions. So you're basically going to take all of the concentration units that you already had looked at, these ones all right here, and the purple lines show like you're going to turn this one into this one, and this one. And then you're going to take this one and convert it into this one and this one. You know what I'm saying? You're just changing them all up. So that's how the week is going to end, is by doing that. Please allow enough time to practice on that particular homework set, because sometimes they go faster and sometimes they're slower. You're definitely welcome to ask on the discussion board if you've got any questions.